some values. How many remember getting an email from me about that? What was it, Nicholas?
Bring in some values for your system that you liked that would be somewhere less than quarter decay. That's
right.
Paraphrasing as I understand it.
That sounds familiar. Did you do that?
I did.
What system we talking about?
Pressure.
Okay, let's click on pressure. And we're going to do a proportional only control. All right? Right?
Yes.
And let's run this for about 60 seconds. And what's your baseline bias?
20.
How much?
20.
20.
No, I'm sorry. That's the, no, it was 43.
43. And we're going to run this 60 seconds. All right, and this gain?
1.1.
How about 1?
That works.
Hello? 1 significant digit on tuning parameters. That means K sub C and later on tau sub I. 1 significant digit, no more. Waste of time and energy. Confusing. All right, set point?
20.
How much?
20.
20. You said 20.
Yes, sir.
And change?
5.
Let's do 20 just for fun.
Sweet.
And we're going to do this in 30 seconds. Dampers?
Closed.
Always closed.
Yes.
Okay, I think we got it. We're going to run this 60 seconds. Baseline bias value 43. Proportional control gain, I'm choosing 1 instead of 1.1. Initial set point 20, change set point 20 after halfway through, and the dampers are closed all the time. Let's just see what happens here. All right, what happens over here?
Madness.
Noise, we don't worry about it. Throw it away. Who was it? Was it Stuart? You were showing me some of these things that you just cut and paste up there. That's some garbage over here, right? Look at this. We're right on. That's because the bias was chosen correctly. The bias is about 40. What looks like about 44. What was it? What was
43.
And here's the input, the blue, and here's the output, the red. What do you notice about the output and the set point?
Offset.
Over here is sweet, because we're smart and we chose the bias right. But after we change the set point, what do you have noticed happening, Christos?
Not so sweet.
There's an offset there. What did I tell you earlier about offset?
It's related to your dead time and your tau relationship.
Just for fun, let me run another experiment. We'll get back to this, okay? We'll run another one. I'm going to run another pressure experiment. There's the proportional control. point of 20. And 20, I'll be at 30 seconds. And I'm gonna leave those at 0, that's just the default, thing we changed. This ought to be interesting. I mean, think this is gonna be interesting.
I do, Dr. Henry.
You do?
Yes.
Look, right on.
Wow.
Right on. Green is the set point. Right on.
It's fantastic.
Because I chose the bias correctly. I mean, I could have maybe done a little bit better, so it's right on there. Then at 30 seconds, this thing's going to pop up. So the set point's at 30 seconds. Look, right on! Is that cool?
It's pretty
Look at
sweet.
that, it's right on the set point.
That's your input. That's your input.
Oh! That's the input, not the output. The output's way down here. Oh, bummer. How'd you notice that?
Are you talking about the lack of air?
What's that?
Are you referring to the lack of air?
Lack of,
Air is pointing towards your,
lack of arrows pointing to it. Wouldn't that be neat if this whole thing had arrows pointing to what you're supposed to see?
Yeah.
And then you wouldn't have to depend on the colors to help you.
I think the font's too small.
Oh, you're so sharp. All right, I'm going to do another experiment. For winter. Here's what I'm going to try to make this easy for you. It's a little bit different than what it says on the website about today in this week's experiment. How about if I make it a little easier for you?
Sure.
You find one of the experiments with P only control that has a decay, quarter decay or less, smaller. Not any of that stuff that goes like this. Your boss throws up when the boss sees things going like that and fires you. Brandon, what do you say about education? All right, if you graduate from here, which I hope all of you do, and you ever work in the area where you're tuning the controller, don't ever let the thing go bananas, or you lose your job. And you have to come back and get an engineering management degree or something like that. I shouldn't have said that. Don't quote me, okay? Have we already talked about who says I shouldn't have said that?
No.
No.
Huh?
I think
Who always says, ooh, I shouldn't have said that.
I think now's a good time to talk about it.
Do you think now is?
Absolutely.
Come on, y'all seen Harry Potter movies? Or read the book? Who says, oh, I shouldn't have said that? Hagrid, yeah, I love that. I'm all the time saying that.
Oh yeah.
I remember that.
Huh? What did he say?
No, that's a guy who played Alan, the old big guy.
It'd be nice if I didn't have to type all these things in. All right, I'm going to do 120. I'm going to do 6. I think the system can run 120 seconds instead of just 60. We'll try it. I'm going to use point. I'm going to use point 2, the same one I just did before for the controller game, and I'm going to use a very large integral times constant and do the same set points, 20 and 20. We'll do this at 60. And I'm going to run this. Now, if I put in a very large tau savant, put in a humongous tau savant. Tau savant is in the denominator. that means that integral term is virtually zero. The integral term, shall I refresh your memory, has k sub c over tau sub I times the integral of the error. So look, just like before, isn't it? Everybody say, yeah, it's just like before, isn't it?
Yeah, it's
It's
just
just
like
like
before,
before,
isn't it?
This, in essence, with that value of tau sub I, is just a proportional controller. The integral term has been, at 60 seconds, this is gonna go from 20 to 40. What do you think's gonna happen? Go up?
It's gonna go bananas.
Bananas? One vote for bananas. Anybody else? Look, it's right on. No, can't fool you twice, can I? What do you notice different between this and the other one? What'd you say, Ashley? Did you say something? Did you say something, Ashley? Huh? Who did?
Bigger
Dave?
offset.
Huh?
Larger offset.
No, it's not larger, it's the same. This is almost the same as the earlier experiment. Because I use the same K sub C and all that stuff. So the proportional integral doesn't do any good if you use too large a value for your integral time constant, tau sub I. Let me choose another value of tau sub I, and let's see what happens. Instead of whatever that is, a million, I'm going to use 2. So what I'm doing here is I'm repeating the parameters for an experiment that I liked, for proportional only. Look, right on. Just like before. And then what's going to happen when the green line goes up to 60?
It's gonna follow it.
What'd you say?
It's gonna follow it.
Wouldn't that be sweet?
Would be pretty sweet.
60 seconds, this is going to happen. I suppose this is curved down a little bit.
It's broken, Dr. Henry.
No. The integral term is saying, hey, 56 is not a very good value to start with, so it comes down. What's happening?
Madness.
First of all, you see that? You see that there?
See ya.
What do you call that?
Kick.
A kick, and it's a proportional kick. Let's measure how high that kick is. That kick is about 6, over here. That kick is about that much, you with me? Don't let me move my fingers. That kick is about on the order of 5. How big was this? 20? And what was the K sub C? 2, or 0.2.
Yeah, test.
What was it?
Point 2.
K sub C was 0.2. 0.2 times 20 is how much?
10.
Oh!
4.
0.2 times 20,
4.
4. I claim this jump is 4. The delta R, change in set point, times the case of C gives you this jump. That's why we call it the proportional kick. Look what happened. Look what happened. It came up here to where it was earlier, and then it started increasing. This is the input, so that the output finally did what?
Increased.
Reached the set point. So what's the offset over here?
0.
Did I tell you it's going to be 0 always for any proportional controller?
There's some ifs that you left out.
Pardon?
There are some ifs that you left out.